Good afternoon, I am Mr. Rich. Thank you for joining and watching my videos. We're continuing from where we left off with the previous video, the trigonometric coordinates. That was technically a part 1. This right here is a part 2 video. We're addressing complexity that can arise with regards to these types of questions. The complexity that arises is when you are asked to plot a point and determine its trigonometric function, but that point happens to fall on one of these quadrant angles. It could be right here, like a 0, 2 pi. On this line, you could have some point here on the pi over 2 quadrant line, something here on the pi quadrant line, and something here on the 3 pi over 2. And you know this right here, 0, 90, 180, 270, and 360. How do you determine what to do over here? It's not hard, and I'm going to show you in this video. You have to remember that in some instances, an undefined answer can come up. Take a reference point 0, 1, reference point here 1, 0, reference point here -1, 0, and a reference point here 0, -1. Keep in mind, when you're looking at the reciprocals and the rational trigonometric functions, that's when the issues can arise. Otherwise, you don't have an issue which arises, because each of these functions is a rational function. Tan is made up of let's abbreviate, sine divided by cosine. Cotangent is made of cosine divided by sine. Secant is 1 over cosine, and cosecant is 1 over sine. So depending on which of these quadrant angles you have, you could have a situation for these 4 technically pure rational functions to have a 0 in the denominator, and you can end up with an undefined. When you just look at sine and cosine, there is no true denominator other than over 1. You can never zero this out because it's a rational function which is divided by a 1. You can never get an undefined, but with these you can. So that's the complexity which arises, and that's what we should look at. Your biggest trick over here is to look at these. For any of these coordinate pairs I've shown you, there's always an x, y format. The x represents your cosine and the y represents your sine. If you're asked to find one of these in terms of tan, you know you'd be looking at tan would be always opposite over adjacent. Tan would always be a y over an x. So in any of these situations where you're seeing an x value of a 0, you'll get an undefined, and you can see that right here. Because here you have a cosine 0, you have an x value of 0 which is representative of a cosine 0, and you put a 0 in the denominator and you zero it out, which is why tan of 90 is undefined. Likewise, tan of 270, you have a 0 here. When you're looking at the cotangent, you're looking at an x over y because that's always adjacent or opposite. In this instances, wherever you have a y value of a 0, you're going to end up zeroing it out because you'll have a sine of a 0 plug in, and that would be in a point such as this, your 0, your 2 pi, and your 180. So if you do a cotangent of 0, or you do a cotangent of 2 pi, or you do a cotangent of pi, you'll get undefined, because in that the rational function component, the sine component, is always 0. You end up putting a 0 in the denominator. Likewise, the same logic applies with these other two, secant and cosecant. For the secant, you know you're looking at 1 over cosine. But wherever cosine was having a value of a 0, you're going to get an undefined, and that would be again over here. You'd end up getting a 1 over 0 with regards to 90. 1 over 0 here with regards to 270, and similar logic for cosecant where you have 1 over sine. So wherever the y coordinate is 0, you'll end up having a 1 over 0 which is undefined right here and right here. 0, 2 pi, and pi. In these quadrant angles, the y component is always 0. You end up putting a 0 in the denominator. So given that as a framework, let's look at 2 questions. Alright, here's the first question. We have to plot -2, 0, and we have to find tangent with regards to that and secant with regards to that. Let's look at it. -2, 0, it's an x here and a y here. We're looking right over here. We're looking at a pi quadrant angle. When you're looking over here, you know you have to find the tangent. You know tangent is equal to sine over cosine, and you have a -2, 0. This represents my cosine value. This represents my sine value, right? You're going to end up putting a 0 over a -2, which is a 0. So a tangent for this is legitimate and it'll work out. It's no different than you saying tan of 180 and you should get a 0. However, when you look at the secant, let's see what happens. Secant is 1 over cosine, but the cosine value here is a -2. When you do that, you get a 1 over -2, and your answer is -0.5, and again that checks out. Both of these answers should be good. If you were asked for this same question to find cosecant theta, now what happens? Let's add it in. you know you're looking at 1 over sine. But when you're looking at this coordinate pair, the sine is represented by this y value, which is 0. You get 1 over 0, and you get an undefined, and you cannot do it. So that's this question. So for this video, let's look at this last question, the second one. We have to plot 0, 1, and we have to find cosine, cotangent, and sine with regards to this plot. You know 0, 1 lands right over here on the y-axis, which is really your pi over 2 quadrant line. And you know this right here is a realistic example here of a question, because with regards to the sine and the cosine, they each have a range of from -1 to 1. The waves never go below -1, they never go above 1. Whereas the domains for both these functions, sine and cosine, is infinity, minus to positive. But 0, 1 would be a legitimate point on the sine or the cosine wave. Anyhow, you know 0, 1 can be broken down into its x value and its y value. The x value is synonymous with cosine, and the y value is with the sine. So when you're tasked with finding cosine theta with regards to this presentation, you're just reading off this coordinate here, and it's 0, and your answer here would be good. When you're tasked with finding cotangent of this representation here, you're thinking about the cosine value. We can just say the x divided by the sine value, which you know happens to be the y, and you just read it across. You have x divided by y, 0 over 1, and your answer is 0, and it would be right. When you're tasked with finding sine of this angle or representation here, you know you're just looking at the y value, which is just 1, and 1 would be it, and you would be done. So you can see these quadrant angles have a bit of a complexity, but they're not too hard. Let's just throw in, for a discussion's sake, tangent over here. If you were asked to find tan theta, you know in that case you're looking at sine representation here, which is the y, divided by the cosine aspect, which is the x. Now when you're looking at this, you're looking at a 1 over a 0, and that's undefined. Clearly you cannot do it, and that's your answer. It's an undefined. But you can see how this video has evolved, and slightly it's more complex and difficult of a subject material than the previous one, but you should be familiar with this, and hopefully this video addresses any unfamiliarity you have with this specific topic. Stay tuned, more videos on the way. Thank you for watching. Have a nice day.